So with that, I'll hand it over to Mr. Brueckner to run the panel.
All right, folks, thanks a lot. For those of you that don't know me, I have a publication called InsideHPC that focuses just on this market. It has daily news. InsideHPC.com, there's my plug. So I want to do an introduction in a proper way. One time, I don't know, about 10 years ago, I was giving a presentation in Taiwan. And the local people told me, you must do this when we start, you have to do it the right way for this culture. And they said, first thing you do is tell the audience that you're not worthy. The second thing you do is make a joke. So I'm going to do both of those with one swoop here. So I was on this boat ride in Switzerland, right, with a bunch of HPC scientists. And I was showing them my neat HD camera that I use to record PowerPoint. And I'm all proud, and we're drinking beers. And then this one German scientist, he decides he's going to bust my balls, right? And he goes, oh, so do they make them for men as well? Anyway, so that's my intro. Welcome to the panel of CXOs. And, this thing about not being worthy, the intellectual power in this room, I don't know if you've picked that up, but people like Adrian Cockcroft and all these people, I feel like a mental pygmy here, but these guys are doing it, walking the walk. And in fact, if you looked at the agenda, I've added somebody, because I get to do that. Peter Hopton from Iceotope is our, Thomas Sohmers is boy genius, right, from Rex Computing. Kevin Canady from, what's it called, Turbostor? John Melonakos from ArrayFire. Jason Stowe, Cycle Computing. And my good friend over here that I just met today, Leroy. All right, man. All right, here's the deal. This panel isn't about who's got the coolest technology in HPC and which one you should invest in. We're here today to talk about the challenges these guys face in a startup. How did they, how did they decide to organize facing the unique challenges of the HPC market? And what I'm going to have them do first is go down the line here and give us the 2-minute version of what their company does. And then we'll do some questions, and I want this to be an interactive thing rather than just my questions. So let's do that first. So, Pete, you have to use this or they won't hear you.
No problem. So my name's Pete Hopton. I'm the founder of Iceotope. We're a total liquid cooling hardware vendor, a total liquid cooling technology company. What can I say very quickly? We are, in terms of the challenges of this market, we have not only the challenge of the HPC market, but also the challenge of the data center market, because we're doing rack level architecture that kind of mashes the two together. So maybe there's some things I can provide in terms of enlightenment relating to two different markets. Some of these guys might be doing software, hardware, mixing stuff, so yeah, we'll see.
Hi, I'm Thomas Sohmers, founder CEO of Rex Computing, and Rex Computing is developing a new both instruction set architecture, core design, chip based on that core, trying to do kind of everything when it comes to new fabless semiconductor, and hope to kind of bring the experience of being the youngest person probably in this room, and kind of my experience starting a company and a bit about our technology.
Thanks. Hi, my name is Kevin Canady. I'm co-founder of Turbostor. We're currently in stealth mode, so I really can't say too much about what we're doing, but it's a hardware platform, flash array. We believe we sort of cracked the code on the challenges of bringing performance, but a disruptive economics to the HPC for flash. That's one of the things that's really been holding flash back. Cost too much versus disk, and even though the challenges of getting too much disk and managing that is daunting, flash is still too expensive, and we think this coming year we'll be trying to address that.
Hi, I'm John Melonakos. I founded ArrayFire. That's the leading software company for CUDA and OpenCL sort of accelerated computing. And we have an open source business model on that company. I also just started another company about 4 months ago called BrinkTop, where we're selling build-it-yourself Android tablets. And both of those companies will be presenting here. And I love startups, so I write every night a blog post about HPC startups on notonlyluck.com.
Hi, I'm Jason Stowe. I'm the CEO of Cycle Computing. We're the leading provider of cloud cluster computing software. So we write software that a majority of the Big 10 pharma, quite a few Fortune 500 manufacturing, a majority of the Big 5 insurance companies use to take workloads and be able to run them between different computing environments, a mix of internal or external. We focus a lot on listening to the customer as a bootstrap, and I'm definitely looking forward to answering questions about that process. So we've spent the last 9 years bootstrapping this software business. We were the first software HPC vendor in cloud in 2007. So we've been doing this for a very long period of time, and we've built a great business that actually does things for customers. Last week we were able to announce a 70,000 core HPC run on AWS for a customer of ours, Western Digital, to basically do engineering optimization. So I'm looking forward to talking about all the tech here.
Hi, I'm Leo Reiter. I'm CTO of Nimbix, and we do platform as a service for high-performance computing and big data applications. And actually this morning we just announced that we're extending our capabilities now to the hybrid cloud as well. So we're taking some of our technology and making it available to companies to actually run on premises and either burst up or take management from our public cloud also. So we're very excited about that.
So I'm going to start with challenges of HPC in the cloud, because it seems like all of you have got something to say about this. But I want to start with you, Peter. What's the toughest nut from your perspective of, as people start migrating, like Wolfgang's going to tell us, what do you see as the biggest challenge for moving workloads to the cloud, and how do you help?
So from a hardware perspective and a data center perspective, cloud's a big race to the bottom. It's about a race to become more cost effective, cheaper, delivering units of compute more cost effectively. I do wonder if there's some obscure macroeconomics in play, because HPC itself doesn't need UPS, it doesn't need generators. People can tolerate generally having downtime. So the cost of building HPC infrastructure within one's own facility is cheaper than building cloud infrastructure for sale. So I do wonder if there's some obscure economics at play. Maybe it's cheaper electricity in the cloud. Maybe they're getting economies of scale that you don't get within a dense supercomputer facility within a city center. I think there's some challenges around software running on virtual machines, but then we're seeing cloud software coming out that's enabling bare metal virtual machines under the same single pane of glass. And I think that's going to be a big move forwards towards getting stuff into the cloud. Architecturally speaking, clouds have been very, very similar to HPC supercomputing systems for a while now. Yeah. They might have been on 10 gig Ethernet connectivity, but some of them actually were putting that on top of InfiniBand many years ago in order to consolidate their storage and their interconnect IOs. So, generally, cloud is all 2 processor servers, just loads of them, all looking exactly the same in specification. The storage is often distributed across them. The thing that's changing is people are putting software on them. So,
yeah,
hope that helps.
So, I know, Thomas, you have something to add? That same question from your perspective, please.
So I'm from Silicon Valley, and being a fabless semiconductor company, I'm trying to raise money and be in the environment. Silicon is not hot in Silicon Valley. And so one of the biggest things being a completely bootstrapped fabless semi right now, compared to everyone up here who has raised some capital, I'm assuming, is being in this kind of apps and mobile market, trying to raise, for semiconductors hard, and trying to raise for a semiconductor that is targeted towards HPC. One of kind of our business philosophies is we don't want to try to brand ourselves as HPC, but we're also doing web or some other thing. We actually want to focus on HPC and think that HPC is going to be, and the HPC-like problems are going to be the big problems in the 5 to 10 year time frame. And so capital is hard to come by, I guess, when it comes to just the problems. That's kind of in the area. everyone's trying to reach X scale right now, and it's a very difficult thing when it comes to just the very base, physics things. We're approaching the end of just CMOS scaling, and that's a pretty big wall. And then when it comes to the problems of like just pure architectural design, you've got the big semiconductor companies that are pushing their architectures, and kind of our philosophy with Rex is that that's flawed, and we can make serious improvements when it comes to just the base architectural design.
Peter, did you want to comment on it?
So raising money for hardware,
Yeah.
absolute nightmare.
You've done it.
I've done it a few times.
Yeah.
And it's always difficult. Investors don't want to invest in this country or in Europe in businesses that are making stuff because it's hard to scale, it's quite capital intensive to scale. And of course, the other approach is to have some really damn good intellectual property and license. But in that scenario, it's like, well, investors are scared of backing a business which is just IP based and then potentially having people rip the IP off and ending up in expensive lawsuits. So if you want to go down the IP route, go around and get yourself a gorilla, right?
Yeah.
A gorilla is an investor, effectively usually a strategic. So a big company that's already well reputed for being litigious within the IP landscape, and get them to buy a bit of your stock. Give them a discount. Try and find some strategic things where you're working together, and then you can become more of an IP business instead of a hardware business, because nobody's going to walk over you if you've got a gorilla in the back room.
Yeah.
I mean, my gorilla's Schneider Electric. Yeah. Get yourself a gorilla.
Well, thank you. I love talking about technology, obviously, but he's bringing it home. It's about the money, right? If you're going to do a startup, it ain't just because you want to be Mother Teresa. You want to make some money. So, Kevin, do you have anything to add about this cloud question, or what do you say?
I'm sure there's others that are more qualified. I think it is an economics issue.
Yeah.
And I think what impresses me and encourages me is that the workloads seem to be outstripping the ability to deliver. So for us as technologists, that's great ground for us to cultivate and create businesses around, and I think we have to keep working on the economics to try to make it as cost effective as possible.
John?
Seems like there's two questions here. So
Yeah.
on the cloud computing side, as a software company, I'm a big believer in the browser is going to be the path forward for scientific computing. So things like that are currently installed, like MATLAB and Mathematica and National Instruments, LabVIEW, that kind of stuff. I think all that stuff's going to be in a browser, and so a lot of our strategies is around providing science that way. Around investment, and when I started this company, we looked at PeakStream, RapidMind, Interactive Supercomputing, and Silk. Those were all like the companies that were in our same sort of space, and they had all raised venture capital. And to my understanding, I have yet to be corrected on this, to my understanding was not very good outcomes for any of the entrepreneurs of any of those companies. And so I decided I'm going to stay away from VCs, and we are going to bootstrap, and it has turned out to be wonderful. So when you create a good revenue business and you own the whole thing, it is a much better scenario than a mediocre revenue business where the VCs own most of it.
Yeah, so Jason, you've been very quiet. I know you've got a lot to say about cloud, but...
Yeah, so what's the audience on the challenges question? Let me just ask that first. So what are the challenges from whose perspective?
I would say it's the traditional people that are on Bare Iron today that want the advantages of cloud, but HPC has lagged the enterprise for years in this migration. And what you guys are doing seems to me to be an enabler.
Yeah, so I think if you're talking about from a customer standpoint, there's really a couple of answers to this. So the first one is that research computing is now coming under the CIO, essentially, corporate CIO. So when you look at Novartis, or you look at J&J, or you look at HGST, Western Digital, et cetera, all of those orgs, technical computing is no longer the purview of research IT. In those organizations, and they may be leading indicators, but essentially we've seen increasingly over time that the corporate CIO is not worried about how email and websites are being deployed. They're not worrying about their CRM system. How is that deployed? They're worrying about the tens to hundreds to thousands of servers that are being done for big data, for analytics, for simulation. Basically, all of the technical computing areas are the areas that are hard. So if you're that CIO, there's a few challenges. There's chargeback. How do I appropriately ration chargeback to individual folks? Ironically, cloud is not really that big of a challenge from a practical standpoint in 2014, about to be 2015. People have been doing batch computing for payroll services since the 50s and 60s.
Yes.
So the idea that someone else is going to process your stuff and give you results back to a CIO is really not that big of a deal.
Yeah, yeah.
Just out of curiosity, I want everybody to think very quickly. So I talked earlier about a 70,000 core run. So we ran 70 years of science in that workload. That was approximately 7 decades, so 340,000 hours, or pardon me, 640,000 hours, thereabouts of computing. It was done in an 8-hour time window. So we asked for the 70,000 cores, got the equivalent of number 63 on the top 500 according to our peak, and then turned around and answered back in an 8-hour window. Think of the cost of doing that. I just want you to all think very quickly, I'm going to give you 2 seconds here, of what the cost of running a 70,000 core cluster for 8 hours is. Okay?
Well, if you had to buy the thing, you're talking at least $30 million, right? $10 million for the building.
Right.
And $1 million a year per kilowatt.
And that's
Serious
depreciating over 4 years.
Yes, lots of money, just
So
to do it.
It's $5,500 to borrow it and then turn it off when you're done. So from a cost perspective, when folks talk about cost, where you have strategic workloads that can give you faster answers, and this workload's run once every 3 weeks, it makes 0 sense to buy that. It makes entire sense to borrow it, and this is something that a CIO will see differently. Last thing is you always have to mention security.
Yeah.
So security, but I
Yes.
think people are definitely realizing that AWS and Google have people that sole mission is to be awesome admins and excellent data center experts at scales that are a couple of orders of magnitude larger than what you can afford to have in-house. I think recent estimates on the core counts within those environments are the upper tens of millions of cores.
Tens of millions of cores.
Yeah, I read an article on Enterprise Tech this last week that ballparked an upper end of 4 to 5 million servers in AWS alone. So when you talk about Google, AWS, Microsoft, Nimbix, et cetera, you're adding all of the infrastructure providers in here. There's a tremendous amount of capacity. So at that point, the problem becomes ease of use. So the thing we've been focusing on internally, and I'm not going to give a big plug about this, but basically is that you can push buttons and get results out for key applications. That's the last piece that I think will kind of follow.
Well, just to plug my website, I did a podcast with Jason talking about this big core run, and that'll be on InsideHPC this week, and that's a great I listened to it the other day. It comes out tomorrow, so,
All right, thanks. So I think I forgot the question, but it has to do with biggest challenges of HPC, particularly in the cloud. And I'll speak, as a cloud provider, that what I've seen has been just the infrastructure-oriented mentality of the community and the customer, particularly when you're dealing with companies and you are dealing with an enterprise IT group. It's a build-first mentality. It's, oh, well, I'm going to need, X number of cores or X number of machines or whatever. And I think, much like Jason said, we are very much focused on the solution. So it doesn't really matter how many cores or how much it the infrastructure costs. It's about, I have this data to process, I have this much time to do it, and then now we get into how much it's going to cost to do. And whether that happens on 100 cores or 1 million cores, it doesn't really matter. It's all about, right-sizing the infrastructure and just letting a platform that's designed to do that actually orchestrate that instead of having people actually thinking about how to build a cluster to eventually solve a problem. Just go ahead and solve the problem instead.
Yeah.
Let the orchestration technology that's fully automated actually build the cluster for you, right? Okay. So that's, I think, getting people to think in that mentality that are very much used to building things is probably one of the biggest challenges certainly of selling in this space, right? Sure. And then the other problem is the ISVs that in many cases are kind of lagging what the market wants in terms of consuming software. So everybody wants the Salesforce.com model of buying software, and the ISVs are very much about selling you software packages under ELAs. So we're seeing that change pretty quickly, but it's probably lagging a few years of where it needs to be.
Okay. Jason's got a comment? Yeah.
I want to add one thing? You brought up a very good point. You know, the other problem is ourselves as users. So I was a user before I wrote software to help users.
Yeah.
And our problem was really that you always size the question you're asking to the cluster you have on the floor. And
Yeah,
that
like
really
you decide how
is,
many degrees of freedom that are practical, right?
Right, exactly. What can I run in a reasonable period of time so
Yeah.
I get a result back and
Yeah.
that chips away at the problem? And the biggest thing that we've seen in doing these very large runs is, and most of our customers are using 64 to 6400 cores on a day-to-day basis,
Yeah.
so they're not using giant clusters. But from a practical standpoint, you can ask the big question now. And this is a
Yeah.
really exciting time for that. I remember, you know, working at the Pittsburgh Supercomputing Center. We had a Cray T3D. You know, the 512 cores or whatever allocation you got of that was all you got. That was it. That's all you had. And so the idea that you can go out and ask a big question, use software that is now geared specifically towards making it run faster on those cores, and be able to take advantage of those capacity elements that are available is huge.
Yeah. Well, guys, Peter's got something here, but I want to make a point before he. Our friend Wolfgang Gensch, who's going to talk later, he did some surveys of cloud users trying to find out what came out of that. If I remember the numbers right, 99% of engineering jobs are still done on a workstation, not in a cloud, not on a cluster. 99%. So I'm trying to reconcile that with what I just heard. And anyone who's got a comment, Peter?
Well, you were saying about you said earlier, research computing lagging the enterprise.
Yeah.
Technologically, research computing has never lagged the enterprise. The enterprise has lagged research computing. Yeah,
Yeah.
always. And that's perhaps why research computing in this particular instance of cloud is lagging the enterprise. But then I think of how many people have actually been consolidating workloads and getting high utilizations on research computing, which is effectively cloud.
Yes.
I mean, they introduced cloud to enterprise because they were at utilizations of 5% on their servers. Along came virtualization. They could suddenly start putting more machines up there and getting a bit variable demand. I also think there's a really good analogy here, which should be presented, and that's Uber versus owning one's own car.
Ooh,
yeah.
Okay. Well,
If
yeah.
you go and book an Uber, you're sharing with other people, it's okay for an occasional ride, you're going to get charged less than owning a car. But if you're using the car a lot, you can own your own, you can have a car specifically tailored for that purpose, whereas you book an Uber, you're getting a Prius. It's almost a perfect analogy.
Yeah, yeah. Up on the, Leo?
Yeah, so actually I'd like to add on to that in a second, but also just back on the engineering, the 99% of the workload. So what we're seeing from our customers is very much what you were saying about, they're not asking the big questions. In many cases, they're actually dumbing down models to be able to simulate them in time. And, so the first step when you actually engage a customer is, they're going to try that same model. It's taking them, 20 hours to do on their workstation. They're going to get the results in 11 minutes, right, on an HPC platform.
Yeah.
And once that happens, then they realize, oh, now I can run a model that's 100 times more complex in the same amount of time, right? So that's, I think first the breakthrough has to be, wow, look what I can actually do with HPC.
Yeah.
And maybe that run cost me $100, right, versus buying a cluster.
Right.
On the economics question, that's actually a great point, and that's why private cloud and hybrid clouds are so important. It's not just about who owns the infrastructure, who owns the data. It's about the cost effectiveness of actually renting it versus actually owning it, right? Or dedicating it, let's say, right?
Yeah.
So it's important when you're dealing with a cloud vendor, understand what their offerings, the spectrum that their offerings cover. If all they offer is public cloud, then you're kind of locked into those economics. It's very difficult to get the costs if you're using a full-time system, and then you could very easily think, well, cloud is too expensive. So if you can actually do private cloud, then you may have some benefits.
Sydney? Okay. So the question is, how do you flex your business model to the different needs?
Well, it's all about economics, right? If you're running the same workload for 24 hours a day, maybe 3 weeks out of the month, then that it may make sense to actually dedicate infrastructure. About your business model? From a customer perspective? Right. Well, I think from our perspective, I think we sell public cloud first. And then once we get into a discussion and the customer says, well, that's not cost effective, then we can actually go down and start dedicating. But I think public cloud is where all your margins are going to be, so that's where you really push first on that end to try to get, renting is always more lucrative than selling, right? When it comes to that. But
Jason?
Yeah, I would also add that you're going to have different deployment models depending on where in the market you are. So Global 2000s prefer to consume in a particular way, mid-caps in a different way, startups in a different way, research or public research institutions in a different way. And I know in our customer base, what we see is definitely different deployment models for essentially comparably the same technology, but just packaged differently and delivered differently between each of the different market segments, because an academic institution that has a grant-based funding model is going to have a different desired way of consuming dynamic capacity than someone that wants to run their own stuff and be accountable, because if they get fired for it, at least it would be them operating it on the Global 2000 side, versus a startup who's just trying to get stuff done as quickly as possible, and I don't want to be necessarily bothered with the detail.
Okay, guys, I want to take this topic and put it in the parking lot, as we say, cloud, and kind of shift gears to this entrepreneur thing that we're doing, right? I want to talk about why you formed your business. What drove those choices? And Peter, you've done a number of startups. Is anyone else a multiple startup? Okay, okay. So let's start with you. How did you choose the business structure that you did?
I worked for other people. I had a few bad jobs. Yeah. And, I kind of wanted to work for myself. I'm quite a good networker. I have to say, one of the things you have to be to start your own startup is networking. Yeah. Always be networking. It's kind of like networking is the opiate of the unsuccessful, but a good network holds the key to most problems. Yeah? What I mean by that is, imagine the guy that's going around at the networking meet, trying to sell his product to everyone, that turns up at every single networking meet. That's networking is the opiate of the unsuccessful. But then think of the guy that goes around the networking meet and gets to know everyone, gets to understand his customers, gets to understand and make friends with his competitors, gets to understand everybody, knows his competitors and their products and his customers and their needs better than he knows his own. That's where a good network is the key to most problems. The other thing, I think, just elaborating that a bit as well, knowing your competitors and your customers, intellectual property, right? The stereotypical thing is you go and invent something, you wander down to the patent attorneys, you put it on his desk, you say, yeah, just file that, right? Actually, what you should have done is, whilst you're inventing it and you got this in your back pocket, you should have learnt about all of your competitors' technologies and all your competitors' patents and the patent landscape, and you should have figured out where you fit there. It's like staking your claim, yeah? Your claim for a piece of real estate, or,
But if you don't know the territory, how do you do that?
If you don't know the territory, how do you stake a claim? Yeah. So you've got to know the territory, know your competitors, know their products, know their IP before you get to the patent attorneys. And then you'll have some really amazing intellectual property. So always be networking, know your competitors, know your customers. Don't be the guy that is the opiate of the unsuccessful.
So Thomas, you have the benefit of youth, right? How did you choose?
Yeah, so I guess how I got into HPC was I was working on a lot of different small, hack-together projects when I was in middle school, and long story short, one of them I made a head-mounted display, and I got invited to MIT Entrepreneurs Club, and I met some students and other people there, and out of that, I got invited to work at a Army Research Lab, Institute for Social Nanotechnologies at MIT, and I was working on miscellaneous, just rapid prototyping of small things for a while, but they have quite a few Beowulf clusters and systems there, and so I met my original co-founder for Rex there, and I guess my experience was just that okay, these systems are pretty cool, and we started working, using ARM development boards, making clusters out of those. But throughout my experience, I just kept finding small problems with, how these systems were designed. And I mean, if you're taking a embedded development board meant to make apps and you're supposed to run Android on it, and we're running Ubuntu. Obviously, it's not going to be the ideal platform.
Yeah.
And so I kind of found just a passion for wanting to make high-performance systems. Like the idea that you just have to keep going forward and building up is exciting. And kind of starting Rex, the thing realized is that of all the architectures out there, none of them are really focused on being high performance and scalable. They don't meet the requirements for today. And because HPC is thought of as a niche market, and all of the big companies out there, they have other cash cows. They just try to make those cash cow solutions fit to HPC. And with my love for HPC as an idea of making the fastest, most power efficient, et cetera, system out there, it's an engineering challenge, and kind of an engineer.
Yeah, that's inspirational.
Just interesting, though, very, very quick comment here. Isn't it great how the HPC market is so engineering friendly? It's, if you think of any other market, you've got to move from product driven to benefits driven really fast. They call it the chasm. There's a book on it, right? Well, here we are in HPC, and the pre-chasm is probably as big as the post-chasm. So, you can be an engineer and you can market based upon product and features.
Yeah. Kevin?
One quick thing to add on to that.
Yeah.
But when it comes to, being engineering focused, the fact that if you have a good idea, you can usually get people to listen to it, and that's not necessarily as common in other industries. And so.
Yeah.
So this is a question I've been really
We've talked
challenged
about,
with
yes.
for about quite some time, because it's so easy for us in this industry to talk about how we're doing something and what we're doing, and we gravitate, given this engineering background, to get really into the technical perspective of what our product or service is, but we lose sight to that very first question that you posed, which was, why are we doing this?
Yes.
And that why is a real clear vision that you have to have. And it's something that you have to spend a lot of time. It's really uncomfortable for us to talk about why we're doing this. Why do we go through the heartache of a startup to take on this challenge? And I would encourage those that are thinking about startups or in the midst of it, think about that why.
Yeah.
And that makes an emotional connection with the person that you're trying to suggest that your product or service might be a solution for them. And it is probably the most critical element to the three parts.
Yeah.
And if you can have that clear, then it's easy to get into the how and the what you're doing, because then it just naturally follows. Since I haven't had the mic too much, I hope, there's just one little side.
Well, let's get all
point I wanted
metaphysical here. Why are we
just-
here on the planet?
One thing I
Kevin?
wanted to, I don't want to be fair, but I just, there is real challenge in the HPC space about marketing ourselves.
Yeah.
So maybe if we can get back to that point. I wanted to, if it shocked me at the show, like how the organizers of SE don't encourage HPC startups, and just giving us a forum to have like a venue, maybe a pod to present in, something that gives us some little bit of airtime is really difficult. So I commend you and Shanine and the whole team that organized this, because it's a dialogue that needs to now grow and totally expand, because these events, HPC advisory or IDC shows, you got to pay to play.
Yep.
And we are trying to get technologies launched, and we need a forum to do it because we all benefit from it.
Thank you. John?
Thank you. So I'm again, a big startup fan, and I always tell people that are thinking about potentially jumping ship from a big company to a startup that you just need 3 things. You need to be a competent person. People generally know if they're competent enough to do something like that. You need to work on an important problem, and that's really it. And then you have to be persistent. So in my case, I took 5 years, bootstrapped, no venture outside money, and paid myself like nothing for 5 years, and then it exploded. And the whole motivation all along for me was the challenge and the money. Like, I wanted to make more money than any reasonable employer would ever pay me. And the only way to do that is to own your own company.
Well, don't apologize for that. Yeah. I think that's, yeah.
I mean, but you have to. It's very risky, and you have to be persistent. And you have to be extremely comfortable with the opportunity cost. And to the HPC specific comment, I think HPC is actually a terrible place to start a company. Like, it's a terrible market in general.
I agree.
Like, if your ideal first customer is a national lab, you might as well, yeah. You're gonna die.
You're in a world of hurt, aren't you?
So the way I think probably most of us got started is we sell to other sorts of engineers and scientists that are not necessarily HPC. They are more technical computing.
Yeah.
There's a much broader, longer tail of those people, and they're great. So they're in all different kinds of markets, and you can sort of shift around and find ways to make a lot of money that way. But HPC it takes a long time to sort of sell to those big boys.
Yeah, I would just add to that, this market has a terrific track record of putting innovative companies out of business. And it's the nature of the beast. That never stopped anybody, did it? Yeah. So, Jason?
So, you and I have a similar story, it sounds like. I cannot wait to catch up after. It's very simple. I don't know if this is a guidance or why I did this or how we got organized. We did get a little metaphysical. The reason why I'm doing this is I think that there is a renaissance period that's about to start, because something that only people with a lot of money used to be able to get is now available to everyone. And
because of Kickstarter and things like that, you mean? Or why is it so?
Yeah, so you have sources of funding on the product side.
Yeah.
For example, on the supercomputing HPC side, those compute environments that used to only be available to the very rich are now, a couple $1,000, which is affordable.
Right. I'm trying to call Andy Bechtolsheim to invest in my company. I mean, good luck, right?
No,
how do you get his attention?
Well, so the reason why I'm doing this is that I think we're in a period that we're gonna look back 10 to 20 years from now and say this is where it all started, when these resources became available, because printing press was the same thing. It didn't take monks years to write a book. You could print it out on a scalable, cheap, inexpensive fashion, et cetera. So it's the same idea, but this time with computing. I think, from a practical standpoint, though, you have to listen to the customer.
Yeah.
You have to fall in love with the problem, not the solution, right?
Well, that's an easy trap to fall in, though, isn't it? I mean, you created something and it works.
Exactly.
I'd be in love with that.
You have to be able to, you have to be willing to shoot it in the head and say, this is not the right thing, it's this other thing.
Ouch.
Et cetera, and move on. That's something that we've definitely done.
Yeah.
I've done it personally a couple of times, where we would have multiple different pieces of software to solve a particular problem. Didn't resonate with the customer. We thought it would, and we shut it off. And the reason is that you want to love the customer, love the problem, don't love the solution. In terms of the other advice, though, being persistent, all of that other stuff definitely matters.
Yeah.
Being able to find your customer base, find a good conference that has your customer. I think supercomputing is kind of a hard market because there's a lot of customers theoretically here, but it's hard to meet with them. So if you're doing something that's applicable to life sciences, for example, BioIT is a great place to go meet them because they're all there. American Chemical Society annual meetup. It's a great place to
or
meet
SEG or whatever, right?
Because they're all there. If you want to meet with end users, or if your end user is an IT person, find the appropriate place where they all hang out, and then be a good networker. Definitely. All of that is, but it's the go where the money is. Kind of find where the customers are and go sit there. Definitely. So I don't know. There's probably.
Oh, I appreciate that. Thank you.
So the comment about iterative product development is really relevant to fall in love. I mean, I think you want to love the solution too, but if the solution is not solving the problem, then it's not really a solution, right? It's just a way to address something that's not really getting the job done, at which point you need to kind of pivot and do something else or improve that or whatever.
Yeah.
But I'll say, one thing that I just thought about that I think is really indicative of whether or not you have entrepreneurial DNA or not is a very simple question, right? Have you ever, and some people haven't had too many jobs, but let's say you've had a number of jobs. Have you ever left a job without having another one lined up? Is that kind of your normal way to leave a job? Then you're probably pretty entrepreneurial in spirit if you haven't actually started a company yet. If you're always kind of looking to line up your next thing before you make a move, then it's going to be tough to succeed as an entrepreneur without a significant amount of funding or luck or whatever. But I think there's two things, and we've heard different versions of it, but one is you have to be all in, which is that, burn the boats. If you don't believe in what you're doing, 100%, it's not going to work, right? And the second thing is you have to be disruptive, because otherwise, if you do something that's a little bit better than what the giant competitor's doing, they're just going to start doing it as well.
Yeah.
Like we heard earlier, if you do something that they simply can't do because it would cannibalize their revenue stream, that's where you have the opportunity. So you have to find that gap that actually disrupts.
Yeah.
And the example that I like, that I really love in this, it's very sort of tangential, but I really enjoy it, is the Gordian knot story with Alexander the Great, where he was presented with this knot that only a god could actually untie, and he took his sword out and cut it. And that just demonstrated that, look, I did what you said the god did without having to go through all that.
He didn't break the rules.
He made up his own. He moved the goalpost, right?
Yes.
And that's how a small company or an entrepreneur can actually beat some of these gigantic firms that have all this money, is by doing things that they simply either can't do or can't even think of doing, right?
Yeah, thank you. Well, we'll pass it over to Peter, but I want to open it up to the audience for questions. Think of your questions. Peter's going to make one comment on that, and we'll go there.
So engineers like to fix things, right? And often fixing things involves introducing new complexity. And so you get innovative companies that are constantly fixing things, introducing more complexity, fixing things, introducing more complexity. And that's why innovative companies get out of business in this industry, because they get paraded and told they're doing really good for fixing these problems, but they continually introduce new complexity. The ones that succeed are the ones that engineer in simplicity rather than engineering in new complexity. And if you think about Apple for a second here, there's complexity in an iPhone, but they've hidden it behind a whole load of simplicity. And that's why the iPhone and the iPod was so successful. Another little thing in terms of marketing for engineers, one thing I like to say to engineers for marketing is the engineering of serendipity. Think about that.
Wow. All right, 2 minutes left. Who's got a burning question? Wolfgang? You get it, man. You're my bro. You want the mic?
Okay, right to there. Oh, come closer.
Oh, yeah, baby.
A very fine differentiation, which is, it is not owning versus renting, but it is really owning and renting, really depending on what you need at what time. So this, very often the discussion really goes towards owning versus renting. So I have to give up something, what I owned, in favor to something which I now rent. I mean, currently, there are these models out there. This is car share, for example, which companies like BMW establish in big cities. So in big cities, there is a very different car situation, transport, traffic, etc., than outside of these big cities. This is still an exception. In our community, it is really, like Barbara Hutchins from ANSYS in the HP Cast, in her HP Cast keynote, she said, okay, there is owning a car, renting a car, and taking a taxi, taxi is really on demand, and renting is like subscription, for a month or so, and still we all have our car in the garage. We won't give it easily up. So that's very important differentiation.
So unfortunately, we've run out of time here. Oh, I'm so sorry. I know Jason's all over that one. But just go ahead. Wrap it up, man. Here.
Well, so Wolfgang, there are certain situations where it makes no sense to host an email server yourself anymore. So So in different use cases, definitely owning makes sense, renting and whatnot. But at the same point also, I think we all suffer as humans a bias, historical bias, of what made sense yesterday. And that's not always the case of what makes sense tomorrow. That would be the only caveat on that side of it.
Yeah. All right, folks, we're out of time. Can we get a big hand for our panelists?